All right, welcome to another class. This is the continuation on our last class on lowest common multiple, or you can still call it least common multiple, or you can call it smallest common multiple. So in that video, we have actually introduced the meaning of LCM and that the foundation is about you just writing out the multiples of numbers. Now, after writing out their multiples, you can simply bring out the common multiples to them. And out of those common multiples you have brought out, then you are going to choose the smallest one, or you choose the least, or you choose the lowest, and that is the LCM of those numbers. So I did that, using 2 and 4. I did that using 3, 9, and 27. And in that class, I told you that we will be using two approaches to solving the LCM. So the first one, okay, I gave it a name that we can call it tabular, okay, tabular method, and that's what we simply did in the last class. So we use tabular method where we just have to simply create a table like this, and then we find the LCM. So in this video, I want to introduce another approach to you. Maybe you can find this one easier, but trust me, the two methods are similar. It's just that in one we are just having a table, and in the other one we are going to be focusing on writing the numbers, as products of their prime factors. So let's call this method, products, okay, product of prime factors. All right, so we can give this name, okay, product of prime factors method. Okay, that's the method we want to use now. So I logically brought back the same examples that we used in the last video, so that we can always compare. Okay, we already know the answer of LCM of 2 and 4. We know that here we got 4, here we got 27, here we got 48, and okay, in this one we got 81. So these are their answers. So we can always use the answers to actually check if we are going to resort to the same thing that we did, or the same thing that we got in our previous video. So let's use this other approach and see what we are going to resort to. So product of prime factors method. This is simply what we have done before. Now let's take the first example, which is a 2 and 4. So we take our 2, we take our 4, and we simply just write them as product of their prime factors. Of course, you remember, if we are going to write 2 as the product of its prime factor, we are going to divide by 2, and there's nothing to divide with again. So we say that what the product will actually be 2. So the product of prime factors of 2 is actually 2. The product of prime factors of 4, we are going to start with 2. That will be 2. Then we use 2 again, we have 1. So the product of prime factors of 4 will be 2 times 2. So that will be 2 times 2. Okay, this is what we are going to have. Now, let's look at how you actually bring out your LCM from this. So we say now LCM of 2 and 4 now. So in this situation, you have to group all the numbers that repeat themselves in all the what numbers. So you can see that in 2 we have these 2, and in 4 we have these 2. So we are going to group the numbers. None of them must repeat themselves. So it's only this one that we cannot group. So the one that you group, you are going to see it as just a number. So these 2 that we group together, we are going to visualize it like 2, such that we are going to write this out. That will be 2, okay, times these 2. So the LCM will be 2 times that 2, and that will be 4, which is exactly what we got when we use what tabular method. This will become clearer as we do more examples. Let's do number 2. Number 2, we have 3, 9, and 27. So we are going to write our 3, we are going to write our 9, we are going to write our 27. So now the next thing for us to do now is to write these numbers. Okay, we write them as product of their prime factor. So that's the next thing we have to do. So the writing 3 as product of its prime factor will simply be 3. To write 9 as product of its prime factor, let's do it. That will be 3. We are going to have 3. That will be 3 again. That will be 1. So that will be 3 times 3. So we can have 3 times 3. 3 times 3. Okay. And for 27, okay, as time goes on, you may not have to be doing this by the side again, but you can begin with that knowledge. So 3 in 27 will give us 9. 3 in 9 will give us 3. 3 in 3 will give us a 1. So that will be 3 times 3, okay, times 3. That's what we are going to have with 27. So we group anyone that you see that repeats, you have to group them. So we have 3 here, okay. Nothing must what repeat itself. We have 3 appearing in 9 that is still appearing in 27. Group it. So we are going to have this one now that we have grouped together represent just a single 3. This one represent just a single 3, and this is another 3. So LCM now will be equals to 3 times 3 times 3, and that will be 27. Okay. So which is the same thing that we got, well, when we use the tabular method. So number 3 is as simple as this anyway. Number 3 also, in as much you know how to write them as product of their prime factors, so everything become easier. We have 12, 24, and 48. 12, 24, and 48. So writing 12 as product of its prime factors, we have 2, 6, 2, 3, and then we have 3, 1. So that will be give us 2 times 2 times 3. That's what will give us a 12. And then let's do that of 24. It's something you can do very fast since we have actually learned this. We have had these skills before. That will be 2, 12, okay, 2 again, 6, 2 again, 3. Then we have 3. That will be 1. So that will be 2 times 2 times 2 times 3. Okay. That's our 24. When you multiply it, you see that it will definitely give you 24 because we have done that before. So I'm just showing you by the side. I could have just gone straight writing them, but I just wanted to see that's how you write, them out as product of their prime factor. So this one also you can use 2, 24, use 2, 12, okay, use 2, 6, then 2 again will give us 3, and then 3 will give us 1. That's 2 multiplied by 2 in 4 places, then times 3. That's 2 times 2 times 2 times 2 times 3. Okay, so that is how we write 48 as products of its prime factors. Now let's do, if there's anything we can group, then we group it. Okay, these 2 we go with these 2. We have another 2 that repeats itself, okay, in the 3. We have another 2 here that repeats itself with these 2. Okay, we have 3, okay, that repeats itself with these 3. All right, so what we have now is 2 times 2 times 2 times this 2 that is not grouped with anything, and then times 3. So let's write it. LCM now equals to 2 times 2 times 2 times this 2 again, then times this 3. Okay, then times this 3. And then if we do that, you see that 2 times 2, 4, times 2, 8, times 2, 16, 16 times 3, that will give us 48, which is actually the same answer that we got when we use the tabular method. So you can see that we have 9, 27, and 81. That's the last thing that we have here. 9, 27, and 81. 9, 27, okay, and 81. So let's try that also. If we want to write for 9, okay, we have done that one before. Actually, we could just write directly 3. That will be what? 1. So this one will be 3 times 3. Let's do that of 27. That of 27, we have done it also before. 3, 9, 3, 3, 3, 1. That will be 3 times 3 times 3. And of course, that of 81 is 3 times 3 times 3 times 3. So you can do that also for 81, 3, 27, 3, 9, 3, 3, 3, 1. Okay. So let's do our grouping now. So we group these and these. We group these and these. Nothing must repeat itself. We group this and this. Only this one cannot be grouped. So we multiply this by this, by this, then by this. So LCM now equals to 3 times 3 times 3 times 3. And obviously that is equals to what? 81, which is actually the same thing that we got when we use the tabular method. So this is how you go about using the product of prime factors. Okay, let me have it in the comment section. Just tell me which one do you find easier, or which one would you prefer? Is it the tabular method or the product of prime factors? So this is the same practice I gave you in the last video. So I want you to also, do the same thing in this video using this new approach or this new method I've taught you. So you have used tabular method before. Now you should use the approach of, product of prime factors. And let me have your comment in the comment section if you actually got the same answer. Till next class, when I'll be coming your way, remain blessed. Bye for now.